Classes and objects in C#. What is a class? What is an object? What does all this mean? Well, let me explain. Now, classes and objects in C#, they support what's called the OO programming paradigm. What does all that mean? OO programming is short for what's called Object Orientated Programming, and it's a paradigm. A paradigm is just a fancy word of saying a way of doing something, like a method. And if you carry on with your endeavors in programming, you may see this word a lot, so I thought I would bring it up now. So a paradigm is a style of programming. Imagine a chef in the kitchen with some raw chicken. He could roast the chicken, he could boil the chicken, he could fry the chicken, but each one of those is a paradigm, a different way of getting to the end result. So that's what a paradigm is. Now, when dealing with basic programs like building a calculator or something very simple like that, paradigms aren't really important. So for beginners, it's no surprise you've probably never really used any before. When software only has 20, 30, 40, maybe even 50 lines of code, the way of structuring your software is not really that important because it's quite small. OO programming, the programming style, is very important when you have large pieces of software. You might have 20, 30, 100 people working on one piece of software. So code organization is very important. So consider this, for example, if you have lots of lines of code that kind of looks like this, how do you even maintain this? It could be 50 pages long, 1,000 pages long. We need a structure, we need some organization. And that's one of the many elements of OO programming. Now, OO programming, it's a very large, complicated subject that has lots of advantages and lots of benefits, but that is one of them. Now, OO programming, it dates back to the 1950s, 1960s, but it definitely gained popularity, as far as I remember, in the early 2000s. That's when it kind of really kicked off. What we've really been doing so far is what's called procedural programming, where the program starts and we kind of execute each line in order. We might have a method or two, and things are very simple. But again, in very large software applications, this is quite hard to maintain, for example. So OO programming, very big, very complicated subject. I can bore you with the whole ins and outs of it right now, but I don't think that's a good way of learning OO programming. I think the best way of learning is to deal with some real-world examples and actually go through it with working examples. So do you remember the movie Karate Kid, where Daniel LaRusso is painting the house and painting the fence and sanding the floor? And secretly he was learning all of this karate, but not really knowing why. And then at the end, Mr. Miyagi said, "Oh, okay, now test your skills."
Show me paint a fence. Yes!
So for the benefits of staying engaged, that's exactly how I want to teach OO programming. And I think that is a fantastic way of learning OO programming, by learning by example, then coming back in a roundabout loop right at the end. So when I talk about complicated words like instantiation, polymorphism, abstraction, cohesion, coupling, all these complicated things I could discuss right now, but the problem is, in reality, they're motivation killers. And for the interest of preserving motivation and keeping you engaged, I'm going to do this way, and I think that will be a fantastic way of learning this. So classes and objects in C#. What is a class? What is an object? And how does it benefit me? And why should I even use them? So far, if you've been following some of the tutorials we've made so far, we've created some basic examples like multiply two numbers together, where we take two numbers from a user and we multiply them together, for example. And when we take a number from a user, we can represent this as an integer data type, which is quite easy, and that's all we need to do. We don't need to know any more information about these numbers to multiply them together. Similarly, if we take the name from the user, we can store this in a simple data type, which is a string, and we just store the user's name. So very easy. But how do we represent a complex data type, like a user, or maybe an account, like a social account or a bank account, or even a bicycle, like a real-world object, or a sandwich? or even a whole planet like planet Earth or something like that. Well, so far with our kind of procedural programming style, maybe to represent a user, we might have a string. That might be the user's first name, and then another string for their last name, and then maybe an integer for their age, and then maybe a string for their username if they have a username. We could have maybe a decimal or a double for their height. So, the list goes on. There's so many things you can store about a user. And you can see I already have 5 lines of code for all these variables. And this kind of page right here is going to fill up very fast with lots of information. So perhaps I could use these 5 data types here, these simple data types, string, int, and double, to represent a complex object like a user. Similarly, if I have a bicycle, I might want the color of the bicycle, the brand of the bicycle, maybe the measurements, things like that. And that's how I would represent a bicycle object. But how do I kind of put all of these into its own kind of object, for example? So rather than for every user in our application, I can just type user, and we could have our own data type, like a user data type. That'd be pretty cool, wouldn't it? And this is one of the benefits of using classes and objects in C#. So let's have a look how we can actually create our own data type in C#. So what I'm going to do now is create a brand new class. So basically a brand new custom data type that we can use anywhere in our software. So if we go over to the right hand side here, this is the name of our project right here, OO Programming, and it has a little C# icon with a square around it. So I'm going to right click this, I'm going to go to add, and then I'm going to go to class. So once we're here, we can see class has been selected, and down here we can give the class a name. Now, you can call the class whatever you would like, but it's common practice to start it with a capital letter and name the class, to do with its purpose. So what is the purpose of this class? What does it do? What information does it hold? Or what is its primary function? So that way, when you have a very large application with maybe 1,000 classes, you know exactly from the name what it achieves, what it aims to do. So what I'm going to do is create a custom data type called user. And what that is going to do is store information about a potential user who might be using our software. So I'm going to call it user. Then I click the add button right here. And what that does, it creates a brand new class in our project. So this is our project here. We've been working so far, and if you've been watching our previous tutorials, with the default class, which is called program, and we've been working with the main method. So you can see here there's a class called program, and the main method kind of sits inside it. So this is kind of a default class of a console application type. But if we go over here, now we have a brand new class called user. And now we can put some information inside this class right here. So you can see Visual Studio is hinting on what I might want to put in here. Yes, it may be a preferable way of doing this, but I'm going to talk about get and set in a future tutorial, so I'm going to do this slightly differently. What we want to do here in our new class, which is called user, is to put everything about our user. So maybe the user's first name, the user's last name, the user's age, so anything to do with a user. So what I'm going to do, I'm going to define some simple variables in here. So what I'm going to do, I'm going to call it maybe first name, for example, and then maybe a last name, and then maybe the age, something like that. And before each of these, I just want to put this internal keyword. Don't worry about what that means right now. We're going to cover that again in a later tutorial. But what I've done, I've defined 3 simple data types here. So 2 strings and an integer. And all 3 of these are inside the user class. And this is the new class we've just created. So what does all this mean? Well, this is our custom data type right here. Just like an integer is a data type, a string is a data type. Now user is our own custom data type, and it has all of these things inside it. Let's look at an example of what this means. If we go back to our main class here with the main method, we can actually set up what's called an instance of our new class. So just like when we create a string, we might do something like this. But when we have a custom data type, like a new class, for example, the format is a little bit different. So it would be our custom data type, which is the name of our class, which is user. And because we've created a class with the name user, you can see now this is green, and it actually has some information about our class. If I type in bacon, for example, then you can see it's black, there's a red line. That's because we don't have a class called bacon. So now we have a class called user, it's green, and we can actually make use of this. So now we're going to give it a name, just like we do here, for example, with a simple variable. I'm just going to call it USR, short for user. Then I'm going to go equal, and Visual Studio is giving me a hint on what I want to do, and that is exactly what I want to do. I want to create a new instance of our class called user, and I'm giving it the name USR. I can give it whatever name I want, it doesn't really matter. So now I have a brand new variable, just like a variable here of type string. I now have a new variable here called USR of type user. So now if I start using my variable USR and put a dot afterwards, you can see I can actually access these variables I've just created inside our class. So you can see here last name, first name, and age. So let's set up a sample user variable. So if I say user.firstname, and we know this is a string, so let's call him, I don't know, let's call him Bob, right? Why not? Right. Then let's set up a last name for our user, and we'll call him Bob Smith. And then lastly, Bob's age. Visual Studio wants me to put 30. Why not? I'm not sure why Visual Studio is indicating 30, but there you go. So now what I've done here, I've created a brand new user object right here, and then I've given it some information. So these fields here, these are the exact same fields we've defined in our brand new class user, which is kind of like our data type. And we've given it some values here. So what I can now do is actually use this information. So if I do console.writeLine, I can actually output some of this information to the screen. So let's say, let me output the user's first name, last name, and age. And let's keep the console window open so it doesn't close on us. And now let's run the application to see what we have here. So I'm running the application. We can see we're actually outputting all of the values for our custom data type to the screen. So we're setting the values this way, and we're outputting the values of our custom data type like so to the screen. So when creating classes in C#, such as our custom user class right here, imagine this class being a blueprint or a specification. So everything inside our class here is to do with a user. It's not to do with a bicycle or a sandwich or something random. Everything in here is involved with creating a new user. So we have the name of the user, the age of the user. So everything to do with a user. And imagine this being like a blueprint for that, or like I say, a specification. So the process here, what we're doing is creating an object. So just like when we create a simple string variable called name, for example, when dealing with custom classes and things like that, these are called objects. And now you can see where the term Object Orientated Programming came from, because we represent real world things like users, cars, bicycles as objects, like classes. So USR here is the object. This is the data type, which is a class. And this process here is called instantiation. And it's called instantiation because you're creating a new instance of a class. And what we can also do is create a second instance of the same class. So this is the first instance. This is the second instance. We can create 50. We could create 100, for example. So what we can do here is create another user, and maybe he's called Darren Smith, and he's 75 years old. And similarly, we can output his information to the window, as you can see there. So you start to see the true power of object-oriented programming. We could create thousands of these user objects and replicate, thousands of users in our software if we would like. We're not limited to only having user objects. We could have account objects, lots of different things to kind of, bring our software together. And what we can do with these objects here, we can pass them to methods, we can put them in arrays, we can cycle through them in loops, so the limits are endless. But that is only a small sample of object-oriented programming, and it starts with creating classes and new objects. So I hope this helped you get started with your object-oriented journey in C#.